Number 1. Find the voltage between points A and B. Number 2. Find the voltage between points B and G. Number 3. Find the current at points A, C, D, and G. Number 4. Find the resistance X.
It's too difficult. What should I do?
Well then, Karen, do you know the basics of electricity, the resistance, current, and voltage? This is our friend, the charge. Electric charges can be positive or negative. Here, we will seek the help of a positive one.
I'm the charge.
How tired or energetic the charge feels is defined as electric potential. Powerful charge, weary charge, tired charge, exhausted charge. The charge gets tired when he does work. The charge is made up of 6.24 times 10 to the 18th power electrons, and its unit is coulomb. The tiredness of the charge is called potential, and the difference in tiredness is called potential difference or voltage. The amount of charge is called electrical energy. The charge gets recharged by batteries.
Time for me to go. I'm an electron. Each electric charge has 6.24 times 10 to the 18th power of me.
Say, Karen, for the charges, which would make them more tired, A or B?
B, of course. The path is longer.
That's right. It is harder to get through the longer path, so they will get more tired. The difficulty to pass is resistance. The more difficult it is to get through, the more resistance there is. It's more difficult to go through two paths than one. The length of the path is twice as long, so the charges get twice as tired. They get tired because they do work when they go through these paths. For example, they might be producing heat or light. Let's look at some examples of what work the chargers can do. Turn on lights, move a car, vacuum, spin a washing machine. The symbol for resistance is R. The unit is ohms. It looks like a rectangle in the circuit.
Okay, so the rectangle in question 1 was resistance. What does it mean when they're side by side or in branches?
Resistance can be connected like this, in series or in parallel.
Stop! It gets harder. This is why I don't like science.
Here, let's think about resistance as the path through a metal tube, the resistor. Suppose one tube is 10 centimeters long with the resistance of 20 ohm. Remember, resistance is how difficult it is for the charge to pass through. Here, the resistance is 20 ohms. The tube is narrowed by half. This makes it twice as difficult to pass through. The resistance is therefore 40 ohms. The tube is cut in half again. It's a fourth of the size of number 1. It's 4 times as difficult to pass through, so the resistance is now 80 ohms. Now the tube is the same width but twice as long as number 1. This means the charges will have to do twice the work, so the resistance is 40 ohms. This time, 2 tubes are put together vertically. The width became twice as large. It's easier to get through than number 1. The resistance halved by 10 ohms. So, Between these two paths, which is easier to pass through? 4 charges would have to pass through A, but they can split up in B. It's easier to pass through B. That's correct. B, unlike A, has 2 paths in parallel. The charges can split up and go through the paths with more ease. It's as if the paths got twice as wide. Here, you can see how each path will tire out the charges. Now, let's organize what we learned about resistance. R stands for resistance and its unit is in ohms. Let's see what happens when there are 2 resistors. Series add up the resistance of the 2 resistors. Parallel add up the reciprocals of the resistance values and take the reciprocal of the total. Oh no, that's too hard. What are reciprocals? Reciprocals just switches the numerator, top number, and the denominator, bottom number of a fraction. If you're interested, let's see why it's the reciprocal. Think of the voltage as V and the entire resistance as R, and use I equals I1 plus I2. Let me find how many ohms the resistance for number 1 and 2 are. Number 1. The resistors are side by side, so they are series. Number 2. The resistors are in branches, so they are parallel. For number 1, I just need to add up the resistance values. 12 plus 4 equals 16. The answer is 16 ohms. Correct! For number 2, I need to add up the reciprocals. 1 over 12 plus 1 over 4 equals 1 over 12 plus 3 over 12 equals 4 over 12 equals 1 over 3. The answer is 1 over 3 ohms. It was so easy. Wait! You haven't fixed the reciprocal. 1 over r equals 1 over 3. The answer is the reciprocal of that, so the answer is 3 ohms. Correct!